When I first started reverse engineering executables, I had no idea how to separate compiler generated code from actual user logic. In this video, I will show how I approach a binary to quickly locate real program logic. For this, I compiled the same C code into 12 different Windows binaries using MSVC, GCC, and CLang. This represents some of the most common Windows binary pattern you will see. We will go through each one and focus on the patterns you should recognize. This is the C code I use. Look at this. Here I first print input, and from user I will take the input. If user give hello, then this code will print okay, and if not, this code will print no. Here are the 12 binaries. You can see test 1 to test 12, and I will show the compiled commands in this video. I'm using GitHub for analysis, as you can see. So let's start. So let's start with MSVC debug mode with no optimization. This is the command. Test1.exe is created by this command. The analysis is already done. Start with the decompiled version of test1.exe. We can see first at the entry point we have security initialization cookie, then we have a variable, and this variable is returned. So the security initialization cookie will have security cookies, which is not the main code. So the main code is inside srt common main.ach, that is the returned function. So click on this. Now we have to find what this function is returning. So scroll down, and at the exit we can find I_4, and it is also being returned. So what is I_4? Let's see. Yeah, this is. So we get the main function. The main function is taking 3 arguments, which is cmain, and first it is having a security cookie, which is the stack cookie. Then printf dot data. What is dot data containing? The input. The first printed character, not character, string is input. So this thing is was printing, then get as local 3c. At local 3c our input is stored. Now as string compare is comparing the string, and if compared value if this returning 0, then I_4 this printf will print okay, and if not, printf will print no. That's it. Let's start with MSVC release mode. This version is optimized, but still it will have ECH, security cookie, and CFG and other all stuff. This is the command. test2.exe is created by this command. I already analyzed, so my GitHub is not asking me to analyze the executable. This is the entry point. So first we can see the security initialization cookie is here. It is same as previous. Some checking is going on. This second function, it will have our main code. Let's look into it, and we have to find what this function is returning. So scroll down, and we can see it is returning this, and yeah. So what is this? Look at this. Yes, this variable is containing this function, and I think this function is our main function. So double click on it. Yeah, this is our main function. This decompiled function is little bit modified. You can say no, this is not our function. I didn't write this code. This is a very good example how compiler optimizes code. This code is not our written usual code. This code is very much modified. We can see this is the whole compare function is this do while loop. This do while loop is containing the whole compare function, and it is comparing two characters at a time. This is our print function and this is our read function. And if our user 5, if this variable is 0, then we are going to this. If not, we are going to the here. But what this variable, this is containing, this is containing no, and this is containing okay. Yeah. So this do while loop is compare function, and it is comparing two characters at a time, and after comparison, if character is not same, then the code will return this string, which is no, and if comparison is going all good, then it will print this okay. So that's it. And then another security stack cookie checking and then returning. So we can see this version is optimizing our code, and it is not the same structure of our whole written code. So you have to remember this thing. Now we will see the MSVC release mode with disabled cookies. This is the command, and test3.exe is created by this command. This is same as test2 and test3, both is MSVC release mode, but here just cookie is disabled, so nothing major change. Security, it is still having the security cookie, the same as before. Now go to the function and see what this function is returning. This function is returning this one, this variable is this function. So go to this function and we'll see our main code. This is our main code, and as we can see, structure is same as test2.exe, just it is missing the cookie checking part. The do while loop is compare function, comparing comparing two characters at a time, and if comparison is good, okay is printed. If not, no is printed. Same as before, nothing major change, just it is not having the cookie checking part. Now start with MSVC with control flow guard test. This is the command, and test4.exe is created with this command. As you can see, the analysis is done before, so Gidra is not asking for further analysis. This is entry point, and we can see the security cookie is as usual present. This function will contain our code, and our code is at return it is returning this variable, and this variable is containing this function. This is our main function. Yes, we can see the do while loop, and that's it. So the structure of this code is same as test2 and test3. This command adds control flow guard at each function call. This is the difference, but the overall structure is same as test2 and test3. Now start with MSVC with static linking. This is the command. test5.exe is created by this command. Analysis is already done. This command adds static linking. So we will have massive boilerplate in startup. This is the massive boilerplate, and we don't care about this. We will see what this function is returning. So this function is returning this variable, and this variable is having this function. This is our main function. It has the same structure as before, the do while loop, the print and read function, same as before. Let's analyze image VC without .pdb compiled version binary. This is the command, and text6.exe is created by this command. What this command do? This command will remove the .pdb function. The pdb function will contain the database of the program, which is the symbol names like the variable names, function names, etc, etc. So at this version we will see no function names and variable names, which is very common in any unknown binaries in CTF, in crackmes. So as we can see, the first function is the security cookie, then second function what will return our main function. This is having the startup codes. We don't care about this. We care about what this function is returning. This function returning this variable, and it is containing our main code. So this is our main code, and we can see it have the same structure as previous executables. It is having the do while loop, which is compare function, the security checks at start, at end, the print function, the read function, same as before. Let's analyze GCC default compiled executable, which is test7.exe. It is created by this function. The analysis is already done, and I can't say the entry function. Let's search here entry, and here is our main function or entry function. So let's analyze it using decompiled version. We can see this function is calling this function twice. Let's see what this function is having. This function is returning this function. So what we can see, what we will have to see that what this function is returning, and I can see the exit code is this function, and this function is our main code, and this is very much identical to our written C code. It is having the printf function, the gets, string compare, puts. So it's containing all the symbols we used in our main code. So that is how we will find our main code from the GCC default compiled version. Let's analyze executable of main JW compiler with stack protector. This is the command. test8.exe is created by this command. This is our entry point, and our entry point is having the function, this function, and calling it twice. We have to go to this function, and we have to see what this function is returning. Let's see, this function returning this function. This is our main function. Go to this function, and we can see the same function as before, but it is having this and this stack guard. This stack guard is present to prevent stack overflow. If stack overflow happened, then it will give an error. That's it. Let's analyze executable by main JW, but with ASLR. What is ASLR? It is address space layout randomization. That means when you execute the binary, it will not load at its default address. The ASLR will randomize the starting address of this executable. So let's see. This is the command, and we can see the structure is similar as before. But when you analyze it at runtime, that means using debugger, the starting address will be different than default. That's it. Let's analyze main JW static link binary. This is test10. This is the command, and test10 is created by this command. Here we can see the structure is same as before, but the static link is happened before the entry point. So so at entry point we can't see any static link. This type of call is easier to analyze. Okay, let's see. tst.11.exe, it is created by Silang. This is the command. Let's see, and we can't see any entry point. Let's still write entry, and this is our entry point, and we can see it is similar with test1. The security initialization cookie is present, then there is a function, and this function will return our main function. It is what is written, it is returning this function. Let's see, analyze it, and we can see this is our main function. This is print function, this is read function, this is comparing, string compare, and the name is very similar. And if comparison is 0 0, then comparison is correct. This function is returning, and if not, this function is returning. Yeah, this function. So yeah, this function is print function. Yes, we can see here the 00401080. It is print function. It is also print function. It is also print function, and this is having the hello. Sorry, this is having input. This is having okay, and this is having no. So if comparison is okay, then this portion will be called. If not, this portion will be called. That is no. That is no, and this is yes or okay. Yep, this is test11.exe. Let's go to test12.exe, which is Clang with MSBC toolchain. This is the command. Let's see what it is having. Let's go to entry point. Yes, this is entry. And where is the we accidentally closed the decompiler portion. Yes, here is the decompiler and entry function. This is our let's go to our entry function. This function will return our main code, and as you can see, this is our main function. It is same as before. Stack cookie. If yes, if comparison is good, then yes, and if not, then no. So that's it. We can see the most of the pattern is very much similar. We just have to find the returning function, and that's it. We will get the main function from all the mess created by the compiler. And we also saw the optimized code is very common in binaries.